It was the first of its kind, a pioneering innovation that would go on to shape the world as we know it forever. But it wasn't born out of a hopeful planet striving for efficiency or a company trying to turn a profit. It was born out of desperation, a bid for survival, and in a world in the midst of an industrial-scale war. But out of that conflict, the Allied powers managed to create something that is as amazing as it was seemingly ordinary to us in the modern day. But how did they do it? What were the impossible challenges that faced them, and could they complete such a mammoth project before the war caused the world to crumble? Well, let's dive in to the depths of 1940s Europe to find out, shall we? This is the story of Operation Pluto. The year is 1942 and the world is currently fighting a war the likes of which has never been seen. American soldiers are bogged down in the Pacific. The Royal Air Force had seen off the Luftwaffe during the Battle of Britain, and the Soviets were in the middle of turning it around in Stalingrad. The Wehrmacht push had gone on long enough. It was the Allies' turn to go on the offensive. They wanted to retake occupied France and drive the Germans all the way back to Berlin. But there was a problem. Warfare is all about two things: logistics and momentum. The Allies knew that invading Europe was going to be a military maneuver on a scale never seen before. Staging the largest amphibious landing in history would require an enormous logistical operation by itself. But once the armies landed on the beaches, how could they keep that momentum going? Fail to supply the troops with the things they need, and they'll be counterattacked and get bogged down quicker than you can say stalemate. It's common belief that an army marches on its stomach, but armies use 6 tons of gasoline for every ton of food that they consume. The real limiting factor for an army isn't guns, ammunition, food, or even morale. It's fuel. The British War Office estimated that 60% of all the weight of supplies needed for the push into Europe would come from petrol and oil. The message was clear: keep it flowing at all costs. But how could the Allies possibly keep their forces fueled after they landed? The standard procedure would have been to transport oil over the English Channel in tankers. But this had several downsides. First, tankers would be vulnerable targets for the Luftwaffe and U-boats. Keeping them out in the open, a really bad idea. Stop the oil, and it doesn't matter if the Allies were on the outskirts of Berlin itself, things would still grind to a halt. Second, the weather in the Channel could stop the tankers getting through to provide vital resupply, making them unreliable. And third, ship-to-shore style pipelines would get in the way. Other valuable resources like bullets and food would need to be resupplied in the same way, and having a million oil tankers in the way was going to gum up the process somewhat. The Allies needed a different solution: to get fuel from Britain to France quickly and efficiently. If you're online, you're being tracked by advertisers, your ISP, even hackers, and that's where today's fantastic sponsor, Surfshark VPN, comes in, because they put an end to that. With Surfshark, you can browse securely, you can block trackers, you can protect your data on unlimited devices. No more creepy ads following you, no more risking your personal info on public Wi-Fi. Clean web blocks malware and pop-ups, and no borders mode keeps you connected everywhere, and with one account you can protect all of your devices. Right now, you get 4 extra months for free. Just go to surfshark.com/mega and lock in this deal. Don't browse unprotected. Just go to surfshark.com/mega now and get 4 extra months for free. A pipeline under the ocean. The idea came from a Mr. Arthur Hartley, the chief engineer of the Anglo-Iranian Oil Corporation, after seeing the ability that long pipelines had in carrying oil across the desert. What if the same thing could be done under the English Channel? He spoke to the MP Geoffrey Lloyd, who was in charge of the UK's fuel policy, as well as Lord Lewis Mountbatten, the chief of combined operations, to get started. It was a bold idea. Undersea oil pipelines had barely ever been tried by 1942, let alone across dozens of miles in harsh waters with enemy planes and submarines roaming around. The idea, if it worked, would be able to supply Europe with all the oil and petrol it needed to keep pushing the Germans back. But it threw up some major complications of its own. How were they going to lay a pipeline that far without being able to construct it on location? You could hardly get an underwater welder to fit it together in the 1940s. How were they going to stop it from being attacked while they tried to lay it? And how were they going to hide the whole thing from the Germans in the meantime? Well, Hartley's idea was to use existing underwater cable technology, like was used for telegraph cables, as a base for the oil pipeline. A lead pipe that was just 3 inches in diameter, far smaller than the pipelines we use for similar purposes today. That lead pipe would be wrapped in 2 layers of paper tape, 1 layer of bitumen, prepared cotton tape, jute bedding, steel armor wires, and an outermost layer of jute servings. This would keep the pipeline strong, flexible, and water resistant. It would be a marvel of modern engineering, being manufactured by specialist machines in continuous lengths of 40 miles. As it was made of lead, it was flexible enough to spool around drums for transport. As the brainchild of Hartley, the Anglo-Iranian Oil Corporation, and Siemens, the manufacturers, it was given the name the Hace Pipeline. Because it was made in one large section and could be spooled effectively, specialized ships could lay the Hace Pipeline at a continuous speed by sailing across the channel, and the Allies wouldn't have to worry about leaks until the pipeline was damaged. It also ensured that a pipeline could be laid entirely in a single day, minimizing the risk of an Axis bomber spotting it in the water. But it wasn't the only design of pipeline available. Lead was heavy and wasn't always in great supply because of the war thingy that was going on, and with thousands of tons of the stuff making up one single pipeline, it made sense for the Allies to have a backup plan from a different material in case of shortages. That plan came from Mr. Henry Alexander Hamel, chief engineer of the Iraq Petroleum Company, and Mr. Bernard Ellis, chief engineer of the Burma Oil Company, and thus the Hamel pipeline was born. Now, the Hamel pipeline differed to Hace in several ways. Firstly, it was made of steel, and rather than being produced as one continuous pipeline, it was cut and welded together in factories. It was also 3.5 inches in diameter, as opposed to Hace's 3, in theory allowing for greater fuel flow. It did have a smaller amount of lead inside as a lining, but the use of steel as a more commonly available material allowed it to be more easily manufactured with less specialized equipment and materials. But steel is a very different material to lead. It's much harder, which made it easier for laying across the channel, as the soft lead could be prone to damage if it was handled improperly. But because the steel was much tougher, it also didn't spool like the lead did, so a new solution was needed to get the pipe in one continuous length across the water. That solution came in the form of enormous cylinders around 10 meters in diameter, known as conundrums. While the steel wouldn't coil like the lead to be put on ships, Hamel and Ellis found that it would bend a little, and therefore these massive conundrums needed to be big enough to wrap the steel pipe around it like an enormous spool of wire before a tugboat could tow it out to sea. And between both pipelines, the Allies had, in theory, done it. They'd achieved the impossible in manufacturing an underwater pipeline and having created a process for laying it all at once to keep the Germans none the wiser. And that was all well and good, but when it came to crunch time, would it actually work? And how were they supposed to hide all the infrastructure to transport and store all that oil anyway? The story of the implementation of the pipeline is just as fascinating as its creation. Planning and manufacturing the pipelines began all the way back in 1942 to be ready for the immediate aftermath of the Allied invasion of Europe. But getting everything in place for that time was an enormous logistical operation all its own. Firstly, the Allies needed an enormous amount of oil. Thanks to Uncle Sam, that wouldn't be too difficult, but an entire infrastructure was needed throughout Britain in order to effectively transport oil from other parts of the country all the way down to Kent, where the pipelines would start. Oil storage facilities down in Kent and the Isle of Wight would be prime targets for the Luftwaffe, so a network was designed to carry fuel from less vulnerable storage and port facilities in the west of the UK, such as in Bristol and Liverpool, to the Channel. Throughout the nation, the terminals and pumping stations themselves would need to be hidden to preserve the secrecy of the operation. They were disguised as bungalows, barns, gravel pits, garages, and even an ice cream shop. And here's a fun fact, several of the buildings that disguised pumping stations are actually still there to this day. Down in Kent, the deception continued, with pumping stations being established at Sandown on the Isle of Wight and at Dungeness on the Kent coast, being camouflaged as seaside villas, cottages, old forts, and amusement parks. Lorry drivers who carried oil down to the coast were told to call from public telephone boxes for their delivery instructions to not cast suspicion. Furthermore, the 3-acre fake dock was built at Dover, codenamed Operation Fortitude. The Allies knew the Germans would be watching, and to hide the true identity of where the oil would be coming from, the fake dock was inspected by King George VI, Supreme Allied Commander General Dwight D. Eisenhower, and Ground Forces Commander General Sir Bernard Montgomery. With any luck, the Germans would buy the ruse. It took 2 long years of planning, scheming, building, and hiding, and by 1944, D-Day was fast approaching. Soon after the troops would land, the success of the invasion would in large part depend on Operation Pluto working as intended. The plan was to connect 2 pipelines from Britain to France, both of which were also named after Disney characters. The first, known as Bambi, would travel around 70 miles from the Isle of Wight to the port of Cherbourg, while the second, known as Dumbo, would travel 31 miles from Dungeness to the port of Boulogne. Part of the invasion plans would involve military engineers building pipelines of their own to the French side once land had successfully been taken and held, with plans to extend the pipeline behind the advancing army as long as the Allies had the materials. This would fuel them all the way, they hoped, to Berlin. Back in 1942, the pipelines were trialled across the delta of the Medway, Kent's largest river, and in the Clyde estuary for deep water testing. But now, 2 years and a whole lot of manufacturing and manpower later, it was do or die. If it worked, the invasion would succeed. If it didn't, it could peter out into a stalemate, costing money, equipment, and untold numbers of lives on all sides. This was it. On June 6, 1944, the Allies landed at Normandy on the 5 beaches of Juneau, Utah, Omaha, Gold, and Sword in one of the greatest sacrifices the world would ever come to know. And soon afterward, one of the most ambitious infrastructure projects the planet had ever seen at the time would be put into motion. Like all things, however, the best laid pipes of mice and men do not always go as planned. D-Day had been and gone. The Allied landing at Normandy had been a success, but the Allies now needed fuel badly in order to keep the momentum of their offensive going. The deployment of Bambi began on the 12th of August 1944, with the Haste pipe being deployed first, followed by a Hamel pipe on 27th of August. However, both of these first attempts suffered failures. A successful deployment would not be made until September the 22nd, when a Haste pipe made landfall at Cherbourg, delivering 250,000 litres of fuel per day. A week later, on the 29th, a ship named the Conundrum 2 made her voyage across the channel, towing a 3-inch Hamel pipe, which would be successfully installed at Cherbourg. But soon after, disaster would strike. The pressure of both pipelines was increased on October the 3rd to provide more fuel, but that very same day, they both broke. The Haste pipeline suffered from faulty coupling, whilst the Hamel pipeline had been caught on a sharp edge on the seafloor and sprung a leak. The Allies had to act quickly and decisively. They needed to get the pipelines to France operational, and they needed it very soon. And like all things in World War II, it was the Americans to the rescue. Thanks to the success of the D-Day landings, the Allies had already made considerable progress inland and were already pushing the Germans back toward Paris. This opens up the port of Embassin-Huppain, just north of Omaha Beach, to be reached safely via the sea. So the Americans began delivering that sweet, sweet gasoline to the Cherbourg section of the pipeline via the sea. US troops were now resupplied in France, but the British 21st Army Group, battling through the Low Countries, had started to get bogged down and were desperately short on fuel. With the US helping out down south, the decision was made to cancel the Bambi pipeline altogether, having only delivered a little over 4 million litres of fuel. It's a lot of fuel, sure, but it's not enough to keep an army supplied. The distance from Dungeness to Boulogne was a lot shorter, so it was hoped Dumbo would be more reliable, and so the pipeline at Sandown was diverted to Dungeness. In principle, Operation Pluto had worked. Now they just had to get it to keep working. On October the 10th, 1944, a 3-inch Haste line was installed in just 5 hours by the HMS Sandcroft across the Dumbo route. But that was just the beginning. Another ship, the HMS Latimer, in conjunction with the Sandcroft, would carry a total of 9 2- and 3-inch Haste cables across the English Channel in the following months, with both Conundrum and Conundrum 2 adding a further 6. In total, 21 cables were pulled across the channel under Operation Pluto, equaling a mileage equivalent to the width of Texas and delivering over 1 million gallons of fuel per day. Most of the lines stayed in operation until the end of the war, as Allied armies built fuel lines behind them and raced to Berlin. They had done it. For the first time in history, an underwater pipeline was successfully deployed over miles of ocean in hostile conditions, successfully and to incredible effect. Nowadays, stories like Operation Pluto fly under the radar and get taken for granted, but it cannot be overstated just how important the pipelines fueling the Allied armies were in wrapping up the Second World War's Western Front quickly. It is estimated that between August 1944 and May 1945, Operation Pluto delivered over 172 million gallons of fuel to France. President Eisenhower acknowledged the significance of this feat when he said, and we'll quote here, "Second in daring only to the Mulberry Harbors was Pluto." No, it's not as historically sexy as the D-Day landings itself or the Battle of Stalingrad or the Pacific Island hopping campaign, but Operation Pluto may have saved more lives in the long run on the Western Front than any other action in that theatre. That is something to be commended and celebrated. But Pluto doesn't just have a historical legacy in terms of its impact on the war. It also laid the groundwork for creating a more interconnected world today. In the modern era, underwater pipelines take fuel from all over the world and deliver it to countries across the globe via the ocean, each of them standing on the shoulders of the Allies who pioneered it all the way back in the 40s. It's fair to say that without such ingenuity to rise to a nearly impossible challenge, in incredibly short timeframes, whilst keeping the whole thing secret, the world's infrastructure today would look very different. Thank you for watching.